Hello everyone, and welcome to our video on solving a system of linear equations when we have the infinitely many solutions case, or they might say the dependent systems case. So we have, or when we have this happen, so again, we won't really know that we have the case until we start going at the problem. So let's break down some vocabulary first, though. So we have what's called a general solution in these cases. The general solution to a dependent system will be written in terms of the last variable, which is called the parameter. So like on this problem, there's x, y, and constant. So there's two letters. So that means in this problem, y is what's called the parameter because it's the last alphabetically. So y is the parameter in this problem. There we go, spelled correctly. Whereas the second one, so they told us let z be the parameter. They didn't have to tell us that because we have x, y, z. Automatically z would be the parameter anyway. Okay, so this is, I'm just going to, so say if that wasn't there, well, regardless, the last letter is z, so z is the parameter. Okay, so if they didn't need to tell us that, it would be assumed. Okay, anyway, so we've got a general solution. The general solution will still be in terms of x comma y. A particular solution is when we substitute in values for the parameter. Okay, and actually we'll come back to this in a second. Let me put a little star. But the way that we'll start this problem out, either way, we still need to just set it up. I'm going to use a calculator to show. So to set up the calculator, first remember that these should be in the form ax plus by equals a constant. So this first line needs to have a 4 getting subtracted. So minus 4 to both sides would give us that. The second line, we need to add 6, it looks like. So negative 9x minus 15y equals positive 6. Okay, so we always want in that form. So now it's ready. And then now that it's ready, we can convert it into a matrix. So here's our x, y, and constant. And then we would have 6, 10, negative 4, negative 9, negative 15, and 6. And then from here, we're going to do the RREF function in our calculator. And I'm just setting it all up. So again, notice that we don't need to know whatever case it is. It still starts off pretty much the same. And I'm using the quickest, fastest method for these problems now. And to do it, I'm using my free resource, desmos.com. And I'm just going to go to the Math Tools, Matrix Calculator, and I'm going to enter that matrix. So new matrix. It has 2 rows and then 3 columns. So 6, 10, negative 4, negative 9, negative 15, and 6. And then let's do our RREF on it. And I'm assuming they would want fractions, so I'm going to change it and hit the convert to fraction button. Okay, so it's ready to go. So that's it. So let's press enter. That's ready. All right, so we did the RREF, and now we have to interpret this solution. So when we did it, we got 1 5/3 and negative 2/3. And then the bottom line is 0, 0, 0. So this is similar to what we saw in the last video, the no solution case. So the no solution case, you had 0, 0, 0, but you had 1. So you had an equation that was not true, and then the problem was basically done. No solution was the answer. This, we have a string of zeros. Let me highlight in yellow. But this is true. 0 equals 0. That is true, but it didn't give us an x equals a number or a y equals a number. So when you have 0 equals 0, or if you do it by any other method, you maybe have like 2 equals 2 or 4 equals 4. So if you get something that's true, but there's no letter involved, true, but no letter, but no letter involved, then that means we've got the infinitely many solution case. Okay, so that's what's happening here with this highlighted yellow. So 0 equals 0 is true, but it's not telling us we're done with the problem. We actually have to keep going. So from there, we should rewrite this top one. So this is telling us x plus 5/3 y equals negative 2/3. And what's kind of nice still about the infinitely many case, all we have to do in this equation is solve for this x. So solve for x, which is one step. We just need to minus the 5/3 y over to both sides. So I'm going to squeeze that work in right here. And what we have on our left side would be x and then equals. And the order doesn't matter. I'm just going to keep the negative 2/3 first there and then minus 5/3 y second. Okay, so this is important to us because this is helping us get to our general solution. So our general solution is is going back to this. So our form should be an ordered pair, but they would want this to be a y expression in this case. So y expression, comma, y is the way that this should be written. And then, well, we have the y expression ready. Let me do it in pink. Y expression right here is the y expression that they want right there. Okay, so for our answer, so I'm going to put it right here since I got plenty of space, negative 2/3 minus 5/3 y, comma, y. So this is our general solution. Okay, and then from there, if they want a particular solution, all we have to do is start plugging in values for y. So you could plug y equals 0 in. You could plug y equals 1, you could 2, 3. So that's where the infinitely many solutions come from. So if we can let y equal values to get particular. Oop, it freaked out. To get particular solutions. Okay, so, but we'll see that in a different video. Solutions, spell it right. Okay, so we can let y equal some values, and values that you can kind of determine, or depending on the scenario, we need to look at, well, but that's going to be saved for later. So right now, it's just the general solution, and that's it. Okay, so notice the case. It's going to be a bunch of zeros down below to give us this answer. All right. Or let's see what else we got. So let's see this system of equation. Okay, so that's one of them, the 0, 0, 0. Let's see what happens with this one. Okay, so here we've got 3 variables but only 2 equations. That's all right. At least it is currently set up for us where x, y, z, and then our constant. So we don't need to do any preliminary rewrites. And we have negative 2, positive 2, negative 2, negative 14. And then we have 1, 3/2, 1/2, and 7/2. All right, so again, I'm going to jump to the calculator because it's the easiest and fastest. I'm going to go ahead and do a new matrix, and we need 2 rows is good. We need 4 columns. And then we'll just type it in, negative 2, 2, negative 2, negative 14, 1, 3 divided by 2, 1 divided by 2. Oops, something didn't work there. 1 divided by 2. Oh, I see. So if you just go, so I'm just pressing tab, but it just tabbed it to the start of the fraction. So be careful. Again, always just double check. All right, so that is set up. Let's go ahead and press enter. And there we go. And then now I want to do my RREF on it. It is matrix B. And we've got that there. Okay, and then let's go ahead and change it to fractions like that. Okay, so here we do have a different case than just a bunch of zeros, but it's still going to help give us our answer. So let's write it. I'm going to write it down below. So our x, y, z constant, and we did get 1, 0, 4/5, and then 28/5, and then 0, 1, negative 1/5, and negative 7/5. Okay, so we have this. Well, let's still go ahead and rewrite these equations. So we have 1x equals, so there's no, or not equals, sorry, 1x plus 0y, which we don't need to write. Let's just say plus 4/5 z, so 1x, 0y, 4/5 z, double check everything, and then equal to 28/5. And then the bottom row is, well, there's 0 x's, there's 1 y, and then minus 1/5 z equals negative 7/5. Okay, so notice this right here. There's nothing in it that is false, so no false equation. But it also didn't solve for x by itself. We also don't have no x equals just a number, or y equals just a number, or z equals just a number. So we don't have that either. Okay, but it is telling us, well, because we don't have any false equation and because we don't have this, that is still going to be the infinitely many solutions case. And all we have to do is look at each of these two equations and solve for the easiest variable. So let's solve for x in this first one, which is one quick substitution. So I'm just going to show, just put a minus. I'm just going to put parentheses. Well, actually, let's not even show that. I think that's just making it messy. Notice all you do have to do is subtract that over to the other side. So it would be x equals 28/5 minus 4/5 z. And you could rearrange the order if you really want to. It doesn't really matter. And then for the bottom one, we're going to solve for the y, because it's the easiest one to solve for. So y equals, all we have to do is add the 1/5 z over, so it would be negative 7/5 plus 1/5 z. And again, the order doesn't matter on the right. You could rearrange it if you really want to. And so this is helping us get our solution. I'm going to cloud it. So let's get our final solution. The final solution should be in terms of a ordered pair. So it should be x, y, z, because we have three variables. So x, y, z. But all of them should be in terms of z. So this needs to be in, oops, let me keep it in blue actually. So this should be a z expression. So that's what that's also what it might, or that's what it means to have z be the parameter. It's telling you put these in terms of z. The y also needs to be a z expression. And then, well, z is already z, so I'm good. That one's good. So rewriting these, x is right here as a z expression. So 28/5 minus 4/5 z, and then comma. The y is over there ready to go as a z expression. So negative 7/5, and then plus 1/5 z, and then comma, and then z is ready to go. It's already a z expression. And then that is our, again, this is a general solution. And if we wanted particular solutions, then we could start plugging in values for z, like z equals 1, or z equals 2, or z equals 3. So it depends on the scenario. Okay, but we'll save that for a different time. So for now, it's just the general solution. So our main thing is really just, if we don't get a false, like right here, so false, that's instantly no solution. And if we don't get instantly like this, x equals number, y equals number, z equals number, then that means it's got to be the infinitely many solutions case. And that leaves us with variable expressions as our answer. Okay, so I hope that helps. If you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you again soon.